to solve systems of equations using substitution. Sometimes graphing isn't a practical way to solve a system of equations because where your lines cross may not give you an exact solution. But you need an exact solution, and you can find them algebraically. There are two ways to do this. One method is called substitution, and that's what we're going to work on today. So substitution is something you guys have been doing for a really long time. Remember this kind of a situation here where it gives you a variable with a value x equals 5 and y equals 3, and then it gave you an equation, and we could take these values and actually plug them in. When you do this kind of a thing, what you're doing is you're substituting. You're substituting a number in for that variable. And when you do that, you can then find your answer. Okay, we're going to be doing the same thing today, except with a little bit more complicated scenario. Okay, this time instead of x being equal to just a single number, it might be equal to another amount. We're going to use the exact same process, but instead of plugging in like over on the left side where we plugged in a 5, this time what we would plug in for x is this whole amount. Let me show you what I mean. Okay, on the left here we have the steps that we use when we solve a system of equation using substitution. But the easiest way to do these problems is to really just kind of look at them and think about them and see what we're doing here. So step one, you have to make sure one of your equations is either written as x equals or y equals. Okay, you can't substitute in if you have a coefficient in front there. So when we look at this, we see right here we have that y equals 2x. So since we already have an equation set up as y equals, we don't need to do anything else to that for step number one. Step two says we're going to substitute that value into our other equation. Now the only thing we're going to replace is this variable. Okay, so what we're going to do is we're going to replace this y with this amount. So over here we're going to replace just the y with that amount. Okay, so in this equation on the right here, everything stays the same. We've got x plus 3, but instead of y, what we're going to put in there is this value for y, 2x. And then the rest of the equation is going to stay the same. It equals 56. Now from here, step 3 says solve the equation. So now we're going to solve. We're going to do this distributive property. So I'm going to have x plus 6x equals 56. And then I'm just going to continue solving. X plus 6x gives me 7x equals 56. Divide by 7. I get x equals 8. Now remember, a solution to an ordered pair a solution to a system of equations a lot of times is going to be an ordered pair. In this ordered pair, my x value is going to be 8. So I can start off that ordered pair right away. Now to find the y value of that ordered pair, what we need to do is plug our answer into either of the equations. I'm going to start with this one. This one is a very simple equation. It says y equals 2x. And what I'm going to do is I'm going to take this value for x and plug it in here. So what I'm going to have is y equals 2 times x, which we know is 8, which means if I solve that, y equals 16. So again, if we think about this, I know my y value is 16 right here. I know my x value is 8. Together, those two numbers make my solution to this system of equations. So I have one solution, and that solution is going to be at 8, 16. That's where these two lines will intersect. Okay? In this situation, same thing. We're still going to do substitution, but this time we don't have an x equals or y equals equation. So again, our first step is we need one that says x equals or y equals, and we need to figure out how can I change one of these two equations. The easiest thing to do is going to be to look for an equation where either your x or your y doesn't have a coefficient. And so what I notice is right here, I have just a plain old x. So this is going to be easier to make into an x equals equation because all I have to do is move this y to the other side. If I do that, I get x equals negative 3y plus 7. Okay, so step one, make an x equals or y equals equation. Step two is I'm going to substitute this value for x, okay, into this x. So again, if we think about that equation, I'm going to have 2 instead of x. What I'm going to put in is this value here, negative 3y plus 7. And then I'm going to continue the rest of this equation the way it is. Minus 4y, oops, that's not y, minus 4y equals negative 6. Then we got to solve, okay? So we're going to solve this equation. Distributive property, and I get negative 6y plus 14 minus 4y equals negative 6. Now, what you may have noticed is in this process of solving this equation, or doing the substitution, what happens is we get rid of one of our variables. So our equation started with both an x or a y. When we do our substitution, all we have is either x's or y's, and then we can combine like terms. So right now I have negative 6y, negative 4y, that gives me negative 10y, plus 14 equals negative 6. And then I'm going to keep going. I'm going to move my number to the right side here. Subtract 14 on both sides. I get negative 10y equals negative 20. Goodness, I'm running out of room here. Divide by negative 10. And I get y equals 2. So half of my solution is going to be y equals 2. Now, that's just the y value of the ordered pair. I still need to figure out what the x value of my ordered pair is. So again, I'm going to find the value of the other variable by plugging into one of my equations. When I look at these two equations, I like the way this one looks, x plus 3y equals 7. It seems a little simpler to me because at the end when I plug this in, I'm just going to get a value for x. So I'm going to take this and plug it in here for y. I could use either equation though, okay? Don't worry about picking the wrong one. Either one will work. So I'm going to have x plus 3, and then my y value here is a 2 equals 7. And then I'm going to solve it. All right, so here we go. So x plus 6 equals 7. Subtract 6 on both sides, and I get x equals 1. So now remember, in order to write this ordered pair, my x value is 1, my y value is 2, and that means since we have an ordered pair, we have one solution. Now remember, the other thing to keep in mind is we still have 3 possible scenarios when we do these types of problems, okay? There's the situations where we've talked about right now, which is one solution. When you solve them using substitution and you get an ordered pair, that means you have one solution. But there's also a situation where you might have no solutions, or you might have an infinite number of solutions. Okay, and so what we need to know is how we can tell algebraically whether we have no solutions or infinite solutions. Okay, we can tell when we look at a graph, but how can we tell if we're just doing these algebraically? So what we would do is we're going to do the exact same process. We need to solve using substitution, but watch what happens. So here I've got my y equals equation. So I'm going to take this value and plug it in here for what y equals. So I've got my 6x minus 2, and then I'm going to plug in this value over here for y, 3x plus 2, and all of that equals negative 4. Okay, so now let's solve it. We use our distributive property here, and we get 6x minus 6x minus 4 equals negative 4. So when we simplify, 6x minus 6x, that's 0. So we essentially have 0 minus 4 equals negative 4, which in reality means that negative 4 equals negative 4. When we solved this problem, our variables canceled out. So we didn't have an x equals or a y equals at the end to create an ordered pair. All we ended up with is a number sentence. When that happens, your number sentence is either going to be true or false. In this case, our number sentence was true. Negative 4 equals negative 4. When you get a number sentence that's true, that means there's an infinite number of solutions, infinite solutions. Okay? Now, if that's what happens when it's true, guess what it means when it's false? Let me show you. Okay? So we're going to take this, x equals, and we're going to plug it in here for x. So I've got 2, and then instead of x, I'm going to put negative y minus 2. And then I'm going to go back to this equation, plus 2y equals 8. And now we're going to solve it. Distributive property, negative 2y minus 4 plus 2y equals 8. And again, we have our minus 2y and our plus 2y. That's going to be like 0. So what I have here is 0 minus 4 equals 8, or we can say negative 4 equals 8. Now this is not true. Okay, negative 4 does not equal 8. Oops. So negative 4 does not equal 8. So when you get a statement that's not true, that means there are no solutions. So 3 things could happen. You could solve and get an ordered pair. That means one solution. You could solve and get a statement that's false. That means there are no solutions. Or you could solve and get a statement that's true, and that means there's an infinite number of solutions. So try the on your own problems, and we'll see you tomorrow in class.